Good evening, ma'am. I am B. Sai Chand and I am from IT department, B section. My roll number is 21951A12669. So today's topic is principle of inclusion and exclusion on partially ordered sets. So inclusion and exclusion. Principle of inclusion and exclusion is an approach which derives the method of finding the number of elements in the union of two finite sets. So inclusion exclusion principle, it is the sum rule. If set A and set B are disjoint, then A union B is equal to A plus B. Where what if A and B are not disjoint? So inclusion exclusion principle set 2, A union B is equal to A plus B minus A union B for two arbitrary set A and set B. So inclusion exclusion principle, two sets. So let S be the set of integers from 1 through 1000 that are multiple of 3 or multiple of 5. Let A be the set of integers from 1 to 1000 that are multiple of 3, and let B be the set of integers from 1 to 1000 that are multiple of 5. So it is clear that S is the union of A and B, but notice that A and B are not disjoint. Mod A is equal to 1000 by 3, which is 333. Mod B is equal to 1000 by 5, which is 200. So A union B is the set of integers that are multiples of 15. So A union B is equal to 1000 by 15, which is equal to 66. So by the inclusion exclusion principle, we have S is equal to A plus B minus A union B, which is equal to 467. So this is the inclusion exclusion formula for three sets. So A union B union C is equal to A plus B plus C minus A union B minus A union C B union C plus A union B union C. This is the diagram. So here is the inclusion exclusion for three sets. For n sets, what is the inclusion exclusion formula for the union of n sets? So A union A1 union A2 union up to n, which is equal to sum of the all single sets minus sum of the all two side sets plus sum of all three sides insertions minus sum of all four set insertions, and so on up to 1 minus 1 of n plus 1 into sum of size of insertions of all n sets. So inclusion exclusion n sets. So we want to show that every element is counted exactly once. Consider an element which belongs to exactly k sets, say a1, a2, a3 up to k, in the formula such that an element is counted the following number of times: k1, k2, k3, k4, like that. So therefore each element is counted exactly once, thus the formula is correct. So partial order or poset. Definitions: a relation R on a set is called a partial order if it is reflexive, antisymmetric and transitive. So a set A together with a partial ordering R is called a partially ordered set, poset for short, and is denoted by A to R. A is partially ordered by the relation R. If a transitive relation is irreflexive and asymmetric, a strong partial order, since the relations is less than or equal to on the set of real numbers is the prototype of a partial order, it is common to write less than or equal to represent any arbitrary partial order on A, and then of course the characteristics properties of a partially ordered can be described as follows. So total order: two elements A and B are in A are said to be comparable under if either A is less than or B is less than A, otherwise they are incomparable. If every pair of elements of A are comparable, then we say that A is less than or equal to is totally ordered, or that is A is totally ordered set or a chain. In this case, the relation is called a total order. So Posset or Hasse diagrams. Like relations and functions, partial order have a convenient graphical representation, Hasse diagram. Consider the diagram representation of a partial order. Because we are dealing with a partial order, we know that the relation must be reflexive and transitive. Thus we can simply the graph as shown. Remove all the self loops, remove all the transitive edges, remove directions on edges assuming that they are oriented upwards. The resulting diagram is far simpler. So this is the example of Hasse diagram from A1 to A4, from A1 to A2, A2 to A4, and again A1 to A4, A1 to A3, and A1 to A5. So again A3 to A5, and again A2 to A4. This is one type of Hasse diagram. So that's all in this presentation. Thank you.